Now, this is our second part of our topic, our lesson, which is properties of wave. Now, lesson objectives, what you will learn today. First of all, we will start with the affecting factors of energy of waves. The first one is frequency, is the affecting factor, how it affects the energy of wave. Medium, how does it affect the energy of wave. After that, expansion of wave in the form of wave fronts, how it affects the energy of wave, we will discuss. Then we will start the wave speed. Wave speed depends on what? Okay, first the medium, then temperature and density of the medium. One by one we will discuss about this all. The last one is formulas. I will mention the formulas for the wave speed. What affects the energy of wave? Greater frequency can also mean greater energy in a given amount of time. For most electromagnetic waves, energy is most strongly related to frequency. Okay? In electromagnetic waves, we are able to see which electromagnetic wave has more energy. Definitely, which one has the higher frequency, it has high energy. Which one has the low frequency, that's why that has low energy. As you are able to see here, radio wave actually is not able to harm our body as much as X-ray or gamma ray. Okay, that's why doctors advise us not to be in that room with the patient. Okay, while they are exposed to X-ray or gamma ray, right? Then we go outside, we wait outside. After that, when they are examined, then we can see our patient. Why? Because they are harmful for our body as well. Why? Because they have high amount of energy. That high amount of energy is able to even harm our DNA. Okay, it causes mutation. That's why we should not be near those electromagnetic waves. The second one is the medium. As the wave travels through more of the medium, more energy is lost to the medium. Here, let me read here as well. Often, higher frequency waves lose energy more readily than lower frequency waves lose energy. For example, when you stand far from a concert, you might hear only the low frequency bass sounds. Over here, first of all, I want to start from here. As the wave travels through more of the medium, you know that light energy, light waves are not able to go beneath 100 meters of the sea level. In the sea, in the ocean, after 100 meters deep, darkness starts actually. The wave of the sun, the visible light is not able to pass after that level. Why? Because most of the energy of light has been lost in the medium, which is water. Understand me? How much there are atoms, okay, in that medium, that much the energy is lost in that medium. On the other hand, you may understand this, in the increasing temperature of our atmosphere, right? Why the temperature is increased? Because the sunlight energy, electromagnetic waves which comes from the sun loses some of the energy as heat in the atmosphere. That's why we feel it as a heat, okay, as heat in the atmosphere. That's why actually climate changes. That's why temperature rises in the earth. Okay. The other example is here. On the passage of time, you see on the way actually in the air, the sound wave loses its energy. That's why it is not able to be heard by another person who is far away from the source of the vibration, source of the sound. But as you shout over here, if you shout nearby one person, definitely you irritate him, you annoy him. Okay, because distance is less, the air particles are less, most of the energy is not lost in the medium. That's why it will annoy the person. The second example over here, when you are far away from a concert, or when you are far away from the one car which played music, by the passage of time, when the car goes away, you will hear just the bass sound like this, just about the sound of the singer will not be heard. The sound of singer will not be heard. Just the bass sounds will be heard. Okay, let's listen to music and see the difference of the bass and the voice of the man or singer in this music. Till now there is no bass. Look, the bass has low frequency. That's why low frequency loses less amount of energy in the medium. Bass has been started. You see this one. You see? Yeah, and rise. Away. Oh yeah. Okay. Enjoy the music. Enjoy the music. No problem. Okay, it is enough. Okay. Now, what affects the energy of wave? The last one is expenditure of the waves. Actually, waves spread out, expands in circles or spheres, called wavefronts. It actually expands, it's spread out in the water wave, for example, in circles. Okay. How about in the sound? It expands as sphere to the each and every direction from the source of the sound. Okay, as the circle expands, there is less energy available on the wavefront. Okay, each sphere is called wavefront. Okay, after the production of the wave, in each wavefront the energy level is decreased. As you see in the beginning, the amplitude of this wave is higher, but by the passage of time, you see, when it travels forward on the surface of the water, what happens? You see the amplitude is decreased. It means that its energy is lost. Its energy has been distributed into other molecules actually. Understand me? Actually, total amount of energy all same. It's not lost. On the wavefront, total amount of energy is lost, but by the sharing with the other molecules, what happens? It actually loses in one point. That's why actually amplitude is decreased. You got it? Again, I will explain. Actually, total amount of energy is same on the one wavefront. How much it expands? That much the energy is distributed into other molecules, other atoms, more atoms. That's why it has less energy average. Average, it has less energy in some points. But as a sum of those all energy in the one wavefront, it is same. Okay. Now here as well, the energy is actually decreased on the wavefront because it is shared with a lot of atoms, a lot of molecules as the sound expands. Okay, I think you got. Okay, what determines the speed of a wave? Wave speed, or the speed at which wave travel, depends on the properties of medium. Okay. Now, medium affects the wave speed then. First of all, waves tend to travel more slowly in a denser medium. Denser medium are not able to move as much as less dense medium. That's why it has actually a slow speed. It has low speed in the denser mediums. Okay. Now, sound waves travel at about 340 meters per second in air at room temperature, but they travel at nearly 1,500 meters per second in water. In solid, sound waves travel even faster. You are able to see here, in the different stages of the matter, the speed of the sound also changes. It is slower in the air, but it is faster in the water. It is much more faster in the solid. Okay? You are able to experience it actually while putting your ear on the air. While putting on your ear on the table. When you knock the table, then the sound can be heard much more louder as well as in high speed. Okay, actually in this video I want to show you the speed of the wave in the solids are not able to be noticed. Okay, actually when you produce the wave on the water, water waves can be seen easily because it is slow in the water, but in the solid, like our face, like our body, definitely it is more solid than water. What will happen? The waves will be seen in our face, but as it is so quick, as it is so fast, we are not able to notice it. But thanks to technology, we are able to see in slow motion the waves in our face as well. Now this guy will hit with the ball on the face of this guy. Then the waves of the face, the waves on the face will be seen. In the beginning of the video, you will see that you will see no any waves because it is so fast. But when we use the camera and when we see this in slow motion the video, you will notice that it has the great waves on our face and. Here 1120 times slower.
Oh, it's a clean on the side of the face. Oh, the shockwave. Oh, your nose bone moved under your nose.
Look at the nose.
Oh.
My eyes like, what's happening here?
Oh no, the shockwave in your mouth like hung behind. You look like someone else. Who's that?
Look at the lips.
I look like I'm asleep there. I'm like really peaceful.
Oh, it's class.
Like the first part when I stayed there, but the rest of it moved.
I think it is a great example to show how much fast the wave in the solids. Okay, let's move on. What determines the speed of wave? Again, in gases, wave speed is higher at higher temperature. You see, in higher temperature, the wave speed is much more faster. Okay, how about here? It means that we are able to, talk to someone. We are able to shout to someone in the summer, and he's able to, hear us much more easier than in the winter, right? All electromagnetic waves travel at the same speed in empty space, but they travel more slowly through a denser medium. Okay, when it reaches the atmosphere, when it reaches the water, the speed of the electromagnetic waves are decreased. We actually discussed it before as well. Okay, in the for example, glass also it loses its speed. That's why actually our atmosphere increase in temperature, right? Its temperature is increased. That's why the water temperature is increased, right? While the passing of electromagnetic waves, it slows down. Why? Because it loses its energy in the form of what? In the form of heat. That's why actually we warm up in the earth during the summer, we can say. Here there are some formulas will be mentioned. Actually, the speed of wave has many formulas, but here the frequency, period, wavelength will be actually calculated, etc. But guys, actually we know all the formulas. Why? Because we know that this formula, speed is equal to distance over time. What do we calculate now? Speed of wave, right? What is speed? What is speed? What is the formula of speed? Speed is equal to distance over time. Then we will apply this same formula into waves. Same. It will not be different. Don't worry about that. How? If you know the speed is equal to distance over time, you know all the formulas. Now, one by one, we will check. Let's see here. Look at here, for example. Speed is equal to distance over time, right? Now, what do we want? We want wave speed, right? Instead of speed, you will write wave speed. So simple. Now, what is the distance in the wave, from the beginning of the wave, to the end of the wave? From the beginning of the wave is here, for example. End of the wave is here, for example. What is the distance? What is distance of the one way? Definitely it is what? Wavelength, right? Do you see? One wave speed can be calculated with the distance over time, but distance over time here, distance is wavelength. That's all, so simple. Distance between the beginning and end of the wave is wavelength. And we need the time as well. Time to calculate the speed of one wave. We need the time. What is the total time by the while the passing of one wave? Total time while the passing of one wave. It is wave period. I explained before, right? Wave period shows us how much time passes when the one wave passes, while the one wave passes. Okay? That's so simple. Wave period, time, wavelength, distance, wave speed, speed. Okay? Now, let me clear this all. And look at here first. If the wave period is not given in the question, just wavelength is given and frequency is given. How do you calculate the wave speed? Definitely, instead of period, you will write frequency. Okay? We knew that frequency is equal to 1 over period. Okay? Frequency is equal to 1 over period. That's why we are able to put instead of the period frequency. When you put instead of the period frequency, the formula changes in this way. Wave speed is equal to frequency multiplied by wavelength. Okay? How it happened, I will explain in the next slide. Look at here. Wavelength is equal to wave speed over frequency as well. It is also so simple. Look at here. If actually, for example, frequency, we want to find, for example, wavelength. If we want to find wavelength, it should be alone on the other side of the equation. Then we have to send frequency to the other side of the equation. Then what happens? The multiplication comes here as division, right? Then frequency comes here as division and it can be changed as well. The form of the formula can be changed into this way as well. Okay, let's move in the other slide. Look at here, please. Look, speed is equal to distance over time, and how it is converted. Speed is actually wave speed, right? Speed is wave speed, distance is wavelength, time is time period. Okay, now this one, actually they are same. Now this one and this one, when you combine these two formula, when you put, instead of wave period, when you put the frequency, what will happen? Well, what is that? Wave period is equal to 1 over frequency. Then instead of wave period, you will write 1 over frequency, right? Wavelength, we delete this one. Wavelength divided by 1 over frequency, right? Wavelength, beneath the wavelength there is 1. Actually, I'm not good in teaching math, but maybe some of you don't know these rules. That's why I will tell you. You will multiply 1 and 1. You will multiply frequency and wavelength. Then frequency and wavelength will be on the upper side. Okay? Then 1 and 1 will be on the downer side. And it is not necessary to show the 1 over here. And wavelength will remain there. Okay? It is what happened? Wave speed now is equal to frequency multiplied by wave length. Okay, wave speed is equal to frequency multiplied by wavelength. You see, and it can be converted into this form as well easily. Okay, multiplication can be here as division if you want to let it alone. For example, wavelength. If you want to let frequency alone, then in this time wavelength comes here as a division, and it becomes what? Wave speed over wavelength equal to frequency. It becomes. Okay. Now I want to mention here again, frequency is equal to 1 over period. It means that if you want to change the period in the form of frequency, then it here comes as multiplication. Okay, frequency is multiplied by wavelength. Actually, till now I have explained the formula, but if you ask me which formula is the most important one, this formula is the most important one. Okay, wave speed is the frequency multiplied by wavelength. You have to memorize this. Okay, how it is converted, etc., it doesn't matter if you don't know. Just you should know that these formulas to calculate, actually these two formula to calculate each and every questions, numerical questions about the speed of the wave speed. But here actually till now I showed you the formulas. Just in the next week maybe we will start to calculate the problems about the wave speed.